Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at grade 12, Analytical Geometry, Circles, Tangents. And this question that we're going to be looking at is from the February-March 2018 examination paper. Question 4 reads as follows. It says in the diagram, PKT is a common tangent to both circles at K, A, and B. The centers of both circles lie on the same line, y equals to half x. The equation of the circle centered at O is x squared plus y squared equals to 180. The radius of the circle is 3 times that of the circle centered at M. So let's go and look at the diagram. What do they give us? They give us the equation of this line, which is basically OKM. So this line here, and it's y equals to half x. Remember that it goes through the origin. And standard form of a straight line is y equals to mx plus c. So therefore, by inspection, you can see that the gradient of this line is equals to half, m equals to half. What else do they give us? They tell us here that the equation of the circle centered at O, the circle whose center at the origin is in the form x squared plus y squared equals to r squared. Let's write the equation here again. X squared plus y squared equals to 180. They also tell us that the radius of the circle is 3 times that of the circle centered at M. So therefore, OK, which is the radius of the big circle, is 3 times that of the radius of the small circle. So let's try and write that down. OK is equal to 3 times that of KM. The important thing for you to note is to make sure that you read very carefully and make sure that all the information is on your diagram. It is very important because remember that all the questions will be based on what is given in the question. Let's try and answer the first question. Write down the length of OK in third form. OK is the radius of the big circle. We know that the equation of this bigger circle whose center is at O is x squared plus y squared equals to 180. Therefore, r squared is equal to 180. So for 4.1, r squared is equal to 180. Therefore, r is equal to the square root of 180. Write down the length of OK, third form. That's now done. 4.2, show that K is the point minus 12 and minus 6. There's K here. If you look at it, remember, K goes through the point, or K lies on the point. Y equals to half x. Or I should say K is a point which lies on y equals to half x. And also lies on the circle, which is x squared plus y squared equals to 180. So therefore, we can solve this particular question using simultaneous equations. But remember that they say that K is a point A and B. So what we're going to do is, wherever we got X, we're going to put A, and wherever we got Y, we're going to put B. Right? So we're going to write A squared plus B squared equals to 180, and we're going to say that B equals to half times A. So we'll have our 2 equations. On that note, or point, if you had written x squared plus y squared equals to 180 and y equals to half x, you can still show that K is equal to minus 12 and minus 6. I don't think that would be a problem. So let's go and answer 4.2. 4.2. So let's write down our 2 equations. First equation is a squared plus b squared equals to 180. A squared plus b squared equals to 180. Now remember that this is the equation of the circle centered at O. Let's call that equation 1. Equation 2 would be b equals to half times a. B equals to half times a, and we'll call that equation 2. So now we're just going to substitute equation 2 in equation 1. That means wherever we got b, we're going to put half a. Have a squared plus half a squared, which is equal to 180. Simplifying this, a squared plus half a squared is 1 over 4. A squared equals to 180. So here we got 1 plus 1 over 4 a squared. 1 plus 1 over 4 will equals to 1 plus 1 over 4 equals to 5 over 4, or you can say 1 plus 1 over 4 equals to 4 over 4 plus 1 over 4 equals to 5 over 4. So we'll have 5 over 4 a squared equals to 180. Therefore, a squared equals to 180 divided by 5 over 4. We divide both sides by 5 over 4. So let's go and have a look at that. 180 divided by 5 over 4. That's 144. 144. Therefore, a equals to plus minus square root of 144. And remember now, we want to show that a is equal to negative 12. And if you look at the question, remember that a is up here at a point where x is negative. So it's going to be minus 12. Right? That's a part of, or on the negative x-axis. So x would be here. So therefore, a will equals to minus 12, and b, so we're going to substitute now in equation 2, is equal to half times minus 12, which is equal to minus 6. Therefore, we can conclude that the point k is minus 12 and minus 6. Show that the point k is minus 12 and minus 6. So that's done. Determine the equation of the common tangent PKT in the form y equals to mx plus c. So once again, they want us to find the equation of this tangent here. Let's have a look at that. What can we notice from this? Well, we know that the gradient of this line, y equals to half x, m equals to half. Therefore, what do we know about the radius and the tangent to a circle? Well, the radius is perpendicular to the tangent. So what does that mean? It means that the gradient of the radius, let's just write it down, times the gradient of the tangent equals to minus 1. So the gradient of the radius is going to be equals to, we already got that to be half times the gradient of the tangent equals to minus 1. So therefore, the gradient of the tangent equals to minus 1 divided by half is equal to minus 2. So what can we conclude? We can conclude that the gradient of PKT is equal to negative 2. What's the next thing that we're going to look at? Well, we just solved or showed that the point K is going to be minus 12 and minus 6. Now we have a point to substitute to find the equation of the line. So that's what we're going to do exactly. So let's have a look at that. So 4.3.1, 4.3.1. I'm just going to rewrite what we wrote here. So we're going to write firstly that the gradient of the radius times the gradient of the tangent equals to minus. So we're going to write here that gradient of the radius, which is equal to half times the gradient of the tangent, equals to -1, and that's because tangent is perpendicular to radius. Therefore, the gradient of tangent is equals to -2. So we now know that the gradient of PKT is equal to -2. The point K lies under the tangent, which is -12 and -6. So we'll write down our straight line equation formula, which is y minus y1 equals to m into x minus x1. So we got y1 is -6, so y minus -6 is y plus 6 equals to m, which is -2, into x minus x1. So we got -12, which is plus 12. Y equals to -2x minus 24. Positive 6, if we take it to the right hand side, becomes -6. So therefore we can conclude that y equals to -2x minus 30. That is so the equation of the tangent PKT is going to equal to -2x minus 30. And if we extend this line, you'll see that we're going to have a negative y-intercept. So I'm going to leave it there for this particular video, and I'm going to do a part 2 video to answer the questions that remain in this particular question. So therefore, make sure that you understand whatever we've done so far before we complete this particular question, which would be 4.3.2 up to 4.5. If you haven't subscribed already, subscribe to my YouTube channel, JL Maths. You can check out all the videos at jlmaths.com. Also like my Facebook page, Justin Lazarus Mathematics. And I'll catch you in the next video.